It's not uniform motion. Okay? So when we looked at uniform motion, it was a constant movement in a direction at a steady pace, the same pace. Now we're going to have acceleration, and uniform means that it's going to be constant acceleration, but it's no longer uniform motion. Okay? So acceleration is defined as the velocity's change, or how much it changes over time. Acceleration is always a vector quantity. So what does that mean? What does vector mean? There's magnitude and there's direction. That's the key piece. If there's direction, are we using speed or velocity? Velocity. If we're using velocity, are we using distance or displacement? Displacement. Okay, we're using all of those vector pieces. Instantaneous velocity is when it's at a particular point in time. And so we actually can't look on a graph at 17 seconds and say that this is the velocity or the acceleration at that time. We need a final velocity and we need an initial velocity to figure those pieces out. And then we can pinpoint to time. So there are several equations relating to acceleration, time, displacement, and velocity. And the majority of these that we're going to learn are on your data sheet. So get your data sheets out and make sure that we're looking at the top left of our data sheets. They're on the corner of my counter there. But nope, this island, they're on the corner if you need one. Far, right by the prayer table, down the side, there should be some there. Can you guide them, Daniel, if you can see them? Keep that one. Don't lose it. People go to work every day to make plastic, but let's not keep using it. Exactly. All right. So the first one that we're going to look at, A is equal to VT. That doesn't make sense. A is equal to V over T. V times T gives you distance. Okay, that's one. Another one involves distance. So D is equal to VIT plus 1/2 AT squared. D being displacement, V being the initial velocity, and T being time. A is our letter for acceleration. We're doing acceleration due to gravity, acceleration due to centripetal force, all those different pieces. A is acceleration. Another one, D is equal to VFT minus AT squared. D being displacement, VF being your final velocity, and then A and T squared. We can find acceleration using final velocity being equal to initial velocity plus 2AD. Vf squared is equal to Vi squared plus 2AD. So that's 4. 1, 2, 3, 4. I'm missing one. Oh, another one. There's actually 6, but 5 are on your data sheet. Distance is equal to the average of velocity multiplied by time. So displacement, velocity final plus velocity initial divided by 2 multiplied by time. And then there's one that we don't have on our data sheets. Acceleration is equal to final velocity minus initial velocity divided by t. And if we look at this, what's the units for velocity? Meters per second. And then if I multiply by time in the denominator, what is my units for acceleration? Meters per second squared. Okay. So we need to remember that these are vector quantities, and so when you're doing your answers, not only are you paying attention to significant digits, but you're looking for a direction. And they're really important for figuring out those pieces. Wrong way. So how do you know which equation to use? Well, what have we done so far when we have a question? When we have a question, what do? Write down the values that we know. So which question are we using or which equation are we using depends on the information provided to us. Okay? So it all depends on the variables that we have and the variables that we're looking for. The only thing that you can never do for motion is velocity is equal to distance over time. Even if you squared it. Positive and negative signs, they don't indicate that the object is moving, but indicates the object is speeding up or slowing down. So far, we've been looking at positive and negative indicating a direction. When we're talking about displacement, it's indicating a direction. Now we're talking about, is the object slowing down or speeding up? So if I had a ball, and when it's speeding up, this is what the vector is going to look like. That's the direction of motion. It's moving this way. The acceleration is this way. And so this is a positive acceleration. When an object is slowing down, so it's moving this way, but it's slowing down, the acceleration is shown that way, or it's a negative a. Okay? And it makes sense in terms of what we were using positive and negative before for displacement, because we were showing it as going north or going south. Well, right now, the positive and the negative is just showing an opposite acceleration. If you're moving this way, but your acceleration is slowing down, the arrow will be in the opposite direction. Let's look at an example. The object accelerates north uniformly from rest in a time of 2.7 seconds. In this time, the object traveled 20 meters. What was the final velocity? So if we were to draw a picture, here's our object. It went north, and it went from uniformly from rest. These are how we start decoding our sentences. Uniformly from rest. What do you think your initial velocity is? 0. Nowhere in this question does it say VI is 0, but it does say accelerates from rest. It takes 2.70 seconds, and in that object, the distance moves 20 meters. And it's asking us, what was the final velocity? So when we write it down on the side, VI is equal to 0 meters per second. Time is equal to 2.70 seconds. Distance is equal to 20 meters. And it's asking us to find VF. When we look at all of our pieces that we know, which formula, which equation would you choose? Of the 6 that we just wrote down. Flip back in your notes and look. We just wrote them down. Okay, VF squared is equal to VI squared plus 2AD. In our list of knowns, do we have A? No. So now we have 2 unknowns, VF and A. We have VI, T, D, and we're looking for VF. D is equal to VF plus VI divided by 2, all multiplied by time. Because we have D, we're looking for VF, we have VI, and we have T. So in this particular case, we only have one unknown, which happens to be what we're looking for. First step is to what? Manipulate the equation. Walk us through it, Daniel. Yeah. Move what's on the outside of the brackets first. Okay, did we follow Daniel's thinking? Perfect. So now we've isolated VF and we have everything else. Now we can put our variables in. So Kyle, I'm going to get you to calculate it, and I'm going to get Avery to fact check it. what the answer should be. Kyle's going to say it and you're going to confirm or deny it. So you need to do the calculation as well. Yeah. Give me 3 at least digits. 815, 814. Okay, we're just going to wait for Avery and then we'll confirm or deny it. Yes. When we go back to the question, how many significant digits in time? 3. How many significant digits in 20 in the distance? 3. So how many significant digits should our answer have? 3. 1, 2, 3. So now it says, what was the final velocity? Velocity is vector or scalar? Vector. So what does our answer have to include? Direction. What's our direction? North. How do you get north? Perfect. And our answer was positive, which means that it was going in the same direction. Let's look at question number 2. Okay, a golf ball is hit from the tee box. The golf ball has a speed of 14.6 meters per second as it strikes a tree. The golf ball bounces straight back off the tree with a speed of 11.3 meters per second. If the golf ball is in contact with the tree for 84 milliseconds, what is the acceleration of the golf ball? So here's our tee box with our golf ball. It gets hit, and it hits the tree, and then it comes straight back. It goes towards the tree at 14.6 meters per second, and it bounces back at 11.3 meters per second. The time that it hit the tree was 84 milliseconds. Okay? Always Bob Ross your questions. Always draw it out. So 14.6, what do we call that? When we go to list our knowns. Of what? Which one? We got lots now. Initial speed? Is that what you said? Okay. Cedric, another piece of information. Perfect. Princess, another piece of information. What do we call that? Time. Okay, Cameron, is there anything that you notice we should be doing? Convert the units of what? The milliseconds. Whoops, I wrote meters per second. It's just milliseconds. Okay, if I'm at 84 milliseconds, I want seconds. So in 1 second, there's how many milliseconds? 1,000. Kyle, what do I get for a value? Use your calculator. Go 84 divided by 1,000. This isn't the space to make a mistake. This is not, you don't want to start off the question with a mistake. How much? 0.0. Okay. What's something else we need to pay attention to, do you think, Paulina? We are solving for acceleration. But in this information provided, what's something else we need to pay attention to, Avery? Look at our picture. What do we need to pay attention to? Direction. Why is that going to be important? Because of why? We do need to know the direction of the final answer. We also need to know the direction of what, Daniel? What did we write down the directions for in the picture? Positive and negative what? What are these? What's 11.3 and what's 14.6? Right. Initial velocity is going to the right, and so it's going to have a positive direction. Final velocity is going to the left. It's going to have a negative direction. So make sure you're putting that information in here. Okay, that's why a picture is really important. It helps you figure these pieces out. Okay, I have VI, VF, T, and I'm looking for A. What formula fits the bill? You're 2 for 2, Cedric. Good job. Okay, so VF is negative 11.3, subtracting from 14.6, and then we're going to divide it all by 0.084 seconds. So A is going to be equal to what? Princess is going to calculate it, and Cameron's going to fact check it. What'd you get, Cameron? Negative 11.3 minus 14.6 divided by 0.084. What? Negative 308.3 what? Look back to see what the meters per second squared. Okay, so two things we have to pay attention to. It's acceleration. It's a vector. That piece needs to get done. And we have to look at sig digs. When we go back to the question, we see 14.6, we see 11.3, and then we see 84. So what's my significant digits, Kyle? 2. So 1, 2. 8's going to play a factor on the 0. How do I show 3, 1 being the same as 308? Oh, close. 31 times 100 is 3100. 3.1. It's always whole number, decimal, next number. Never two whole numbers. One number, decimal, however many digits after that you need. So 3.1 meters per second squared. And the negative tells us what? Opposite of the initial direction. The initial direction was towards the tree. What is the opposite direction? Away from the tree. Oh, yes, you do. Thanks, Princess. 3.1 times 10 to the 2. I didn't finish my thought. Absolutely. Scientific notation. How do I find final velocity in this one? Okay, so when I go through the question, the golf ball has a speed, the golf ball is hit from the tee box. Okay? The golf ball has a speed of 14.6 as it strikes the tree. So that is going from the tee box forward. That's the first velocity we come to. The golf ball bounces straight back off the tree with a speed of 11.3. This is the second velocity. So the first one we're going to call it initial velocity, and the second one we're going to call it the final velocity. The formula says that we minus VF minus VI, but the reason the 11.3 is negative is because it bounced off the tree straight back to where it started from. So the negative sign is showing an opposite direction from the initial movement. It takes a bit to process it, so if your thumb sideways, that's okay. I don't have a negative 16.3. I have a 14.6 and a negative 11.3. Does that help, Cameron? Okay. Any other questions before we move on? Understanding the directions is important. That's why I always tell you to draw a picture. I say it every time for the last 7 years. Draw a picture. I do it. People come to me to ask them to help. I draw a picture. Okay? Draw a picture. It helps process what's going on. Read it, draw it, and then write down your known information. Okay? Let's look at the third question. A vehicle traveling along the highway brakes suddenly to avoid hitting a deer that jumped onto the road. Or you could just hit it like I did. The vehicle decelerates at 3 meters per second squared to a speed of 60 kilometers per hour. According to the skid marks on the road, the vehicle skidded a distance of 56.3 meters. Based on this information, what was the initial speed of the vehicle? So it's traveling down the highway and it brakes suddenly to avoid hitting a deer. It decelerates to a speed of 60 kilometers an hour. According to the skid marks on the road, it slid for 56.3 meters. And by the time it came, like when it slowed down, it was slowing down to 60 kilometers per hour. It's asking us, what was the speed when it hit the brakes? So let's write that information down that we have. Acceleration. There's some key wording in here. If you're one that likes to highlight, and I highly recommend it, decelerates is a key word. What sign do you think we're going to use in front of the 3.00 meters per second squared? A negative. A negative, when we're talking acceleration, shows that it's slowing down. The vehicle skidded a distance of 56.3 meters. And it's slowed down to what speed, Paulina? Okay. And Avery, it's asking us to find what? The initial speed before it hit the deer. What's something that we need to pay attention to, Daniel? Yeah, that is definitely one. Cedric, what's something else we have to pay attention to? Yeah, we do need to know direction. Princess, can we help the two boys out? Units. It's in kilometers per hour, and our base unit for physics is meters and seconds. So if I wanted to go from 60 kilometers per hour to meters per second, what am I going to do? What unit are we going to start with, Rayleigh, to convert? Kilometers. In 1 kilometer, there's how many meters? Okay. Cameron, if I wanted to convert hours to seconds, what would I do? In 1 hour, there's 3,600 kilometers, or 3,600 seconds. And I would get a value of what, Paulina? That's okay. I just need this, 60 times 1,000 divided by 3,600. Okay, say it again. Okay, meters per second. All right. We have A, we have D, we have VF, we have VI. What formula are we going to use? Avery, you've actually already said this one. I think so. Okay, look back in our list. We have A, we have D, we have VF, and we are looking for VI. We're looking for VI. So we need a formula that has A, D, VF, and VI. Did you say VF squared is equal to VI squared plus 2AD? That's what I heard you say? Perfect. Okay, if I'm looking for VI, then, Avery, how do I rearrange this formula to isolate for VI? What's this piece right here? How would I move that whole chunk? Subtract it. VF squared minus 2AD is equal to VI squared. But I need to find VI. So what's my next step? Square root it. Okay? VF squared minus 2AD, solve that first, then square root it, and you'll get your VI. And don't use 16.7 squared. Use 16.666666. Use all your digits. Never round until you're ready to put your box around your answer. Okay, so Daniel, you're going to calculate it, and Cedric's going to fact check it. Okay, here's a very key thing, and I love that Daniel made this error. This is an extremely common error. You will forget to square, or you will forget to square root. But squaring is the biggest error, calculation error, that everybody makes. That's why it is so vital that you show your work on a test, on a quiz, on any kind of lab work, because then I can see your thought process. It is easy to remind you to remember to square. It's a little bit harder to help you learn the concept. Always, always, always show your work. You get more marks for showing your work than you do for the answer and the direction. You get 1 mark for your answer out of 3. Always show your work. Okay? Because that's where you're going to make a mistake. All right, when I go back to the question, how many sig digs am I paying attention to? Princess. 3. Oh, the 60. Good catch. 1, 2. The 8's going to play a factor on the 4. So my answer is going to be what, Princess? So 25 meters per second. Did it ask me for speed or velocity? Speed. Speed is strictly going to be magnitude. So I don't need a direction. Okay? So now we're going to work on these questions.